So let's start with the capacitance. Capacitance in series. If we connect a capacitors in a series, the reciprocal of the combined effect of all the capacitance is equal to the sum of reciprocal of individual capacitance. So let's see the example. These are the two capacitors. They are connected with each other in a series. 2 microfarad, and this is also 2. So how we will find the combined value of these two capacitors where the capacitors are connected in a series? This is our first value and this is our second value. As shown in the definition, it is the reciprocal or combined effect of all the capacitance is equal to the sum of the individual capacitor. So after solving these both values, our answer will be 1 microfarad. I think this is the same because we didn't till now did the resistor, so it is opposite to resistor. So first you don't need to think about the resistor calculation. For now just remember the capacitance. If the capacitors are connected in series, we will take the reciprocal of both the capacitors for the combined values. Or in simple words, you can say the first capacitor value multiply and the second one plus, that is called the reciprocal, and divided by each other, that is 1 microfarad is the final answer. This is the second example. 2, 4 and 12 microfarad capacitors are there, so the combined effect will be, first of all we will take these two capacitors 4 and 12. So first will be 12 into 4, 48, divided by 12 plus 4, 16. So the combined effect is 3 microfarad. Now we have 3 and 2, we will solve that. 6 divided by 5, that is 1.2 microfarad. So this is simple. We take the reciprocal of the values of a capacitor to find the final capacitance. Now let's talk about the parallel capacitor. If the capacitors are connected in a parallel, or if we connect the capacitance in parallel, the combined effect of all the capacitance is equal to the sum of individual. So in series we take the reciprocal, and in the parallel we just simply add them. For example, we take this numerical. There are three capacitors in there, 0.1, 0.2 and 0.3 microfarad, and as they are all in parallel, so if the capacitors are in parallel, we just simply add them, 0.1 plus 0.2 plus 0.3. So the combined effect or the combined value will be 0.6 microfarad. So this is the one practice example. There are 1 2 3 4 5 capacitors in this circuit, and these two are parallel and these three are in series. So let's see how we will solve this type of circuit. So first of all, let's start with the right side. We have these two capacitors. We start from this side. These two capacitors are in parallel with each other. So how we solve the parallel one? by just simply adding, because here we say in parallel we just add them. So we add 12 plus 4, that is 16. Now we will move forward. So now we get the 16 value. So now the next one is 16 and 3. So these two are in series. So what was the series formula? Reciprocal. 3 into 16 divided by 3 plus 16. So answer is 2.5 microfarad and 2.5 microfarad. Let's move forward. Now we have three capacitors, 2.5, 12 and 4. So we will take these two capacitors, and both of the capacitor 12 and 2.5, they are parallel to each other. So what we do when the capacitors are parallel to each other, we just combine them or add them. 12 plus 2.5 is equal to 14.5 microfarad. Now the last two capacitors, they both are in series, 4 and 14.5. So what do we do when the capacitors are in series? We do the reciprocal thing, that is 4 into 14.5 and 4 plus 14.5. So the final capacitor value we got is 3.13 microfarad. So whenever you get a question like this on numerical, you have to start from the first side. In this we first solve these two, that they were parallel to each other, and after getting the values we get another capacitor, they were in series, again they were in parallel, and the last two were in series. So you no need to solve these at once, you have to do one by one, taking these two from one side, and from these two values we will apply to the another capacitor and then another capacitor. So do step by step this. So in today's lecture we study about what is capacitor, what is capacitance, what is the working of a capacitor, and then we do some numerical on this. So this was today's lecture, third part. Thank you.